Please open in your learning workbook to page 206. We will now do our next property of logarithms, the quotient property. All right, the quotient property of logarithms says log base a of the quotient m over n equals log base a of m minus log base a of n. All right, so right away we start to notice the differences between this rule, the quotient property, and the previous rule, the product property. With the product property, we had two things being multiplied, and that meant that the logs would be added. With the quotient property, we have two things that are being divided, and therefore the two logs are being subtracted. Here are the instructions for our two example problems. Write the logarithm as a difference of logarithms and simplify if possible. Assume that the variables represent positive real numbers. Okay, here's our first logarithm. Log base 3 of the quotient c over d. Just as before, I'm going to put the log rule directly above it. So we have log base a of the quotient m over n equals log base a of m minus log base a of n. We're going to create a comparison. The first thing that we notice is that the base is 3 for this problem. So a corresponds to 3. The second thing we notice is that the argument c over d corresponds to the m over n in our rule. So m goes with c and n goes with d. We will use these facts to rewrite the log they gave us using this log rule. Everywhere we see an a, we're going to put 3. Everywhere we see an m, we're going to put c. Everywhere we see an n, we're going to put d. So we get log base 3 of c minus log base 3 of d. This is our final answer because there's nothing that we can do to simplify this. We have a letter for the argument here, so we cannot rewrite this logarithm as a number. And we have a letter for the logarithm here argument, and so we cannot write this logarithm as a number. We're done with this particular problem. Okay, let's move on to our next one. The next one says log of the quotient x over 1,000. So the first thing that you might notice about this problem is there is no written base. It just says log. So how do we know what the base is supposed to be? Well, when the word log is written without a base, you are to assume that for this class, with your textbook, your calculator, your work in ALEX, that would be a 10. All right, so now that we know that that's a 10, we can go ahead and write our log rule. Log base a of the quotient m over n gets rewritten as log base a of m minus log base a of n. Okay, what goes with what? A is 10 for this problem. The argument here corresponds to the argument here. So m goes with x and n goes with 1,000. So when I rewrite this, I'm going to have log base 10 of x minus log base 10 of 1,000. Now, we notice that in this second logarithm, I have a number for both the base and the argument. Whenever there is a number for both the base and the argument, you must stop and ask yourself, can I rewrite that in a simpler form? Log is the same as EGOB. Exponent goes on base. So what is the exponent that goes on base 10 to make 1,000? How many times do you have to multiply 10 by itself to get the number 1,000? Well, that's easy. Just count the zeros. 3. So the missing exponent is 3. Therefore, the value of the logarithm is 3. This entire logarithm gets written as the number 3. And then when it comes to this one right here, we're going to put it back the way it was. We're going to drop the 10. And we'll just write log of x. So our final answer for this part of the example problem is log of x subtract 3.